show those things. I thought this was very interesting too.
Okay. Do you want me to show the patent before or after we go through this?
Let's show the footage of the satellites first, and then that.
Okay. All right. So we have some satellite footage that I captured. This is from May 19th, and this is over Texas and Oklahoma. And you can see what looks like gravity waves, again, which used to be a really rare meteorological phenomenon, but they tend to show up every time there's a wind event nowadays. Now, this was during the May 19th tornado outbreak, and there was actually tornadoes going on in Texas and Oklahoma at this time. We did show you the Arnett, Oklahoma tornado, which actually came from a storm system that started in Texas and moved into Oklahoma. As we see here, there's gravity waves present all throughout this area where the tornadoes were occurring. And then I also switched to the radar just to see what was going on. And you can see that there are some beams that are being beamformed out of the transmitters directly into the storms. And I do stop it right here at the end where you can see one beam that's being formed directly into the storms themselves right there. So yeah, that is most likely, to me, for the purpose of ionospheric heating. So if you beamform a narrow beam like that into a storm, it's going to transmit energy to the storm. And if the storm receives some of that energy, you could actually translate it into convective potential. So it will increase the convective available potential energy for these mesocyclones. So anyway, yeah, that was very interesting to me. And I saw that on May 19th, not only during the tornadoes, but around the area where the tornadoes were occurring. I do have another video that I took. This is also from May 19th. This is from the Ventusky or Ventusky app. I do recommend College of DuPage radar and Ventusky and windy.com for catching these things. But I'm going to show this one more time. So what you see here is in the area of North Texas, Oklahoma, and Kansas, you see gravity waves all over the place as a tornado breaks out in Oklahoma. And then as it gets nighttime, you can see in the blue, there's more gravity waves as the are technically called gravity waves. And meteorologists say that they're formed by mountains or formed by wind blowing over the mountains. But out there in the middle of the ocean, there is no mountain ranges to produce those gravity waves. So they must have a different origin. So I think they look a lot like interference patterns. And so one type of interference pattern that you can have comes from a phased array. So this is called a plane wave, which is being formed by the interference pattern from a phased array of antenna elements. So, 5G is this type of phased array technology, as well as NexRad. NexRad is also phased array technology. So phased arrays can produce those kind of patterns, and it looked very interesting to me in Oklahoma. And then as it gets nighttime, you can see in the blue, there's more gravity waves as the Plevna tornado broke out. That was the Plevna tornado that we saw there at the end of that clip. All right, so then on College of DuPage, I started to look to see if I could find these waves that show up, because normally we only see them visually in the clouds, but sometimes you can see them where there's no clouds at, and that's in the water vapor images. So this is the mid-level water vapor imagery from the GOES East.
Billions of gallons of water go into the air every hour from the ponds, lakes, rivers, and oceans all over the world. In fact, everything that dries is giving water to the air. Even wet fields do this. Yep, there's another way water can get into the air. The water on the doghouse roof dried pretty fast in the warm sun. This water disappears faster because the stove is hotter. The cloud from the spout of the tea kettle is condensation of the water vapor from the tea kettle hitting the colder air. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation. As the hot water-filled air hits the colder air near the ice tray, the water vapor turns into clouds of tiny water droplets floating in the air, condensation. When the air is quite cold and cannot hold any more water droplets, they collect together to form larger drops, as on the ice tray. And being too heavy to float in the air, they fall back to the earth as rain. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation. The hot water in the kettle gives off water vapor to the air by rapid evaporation, just as rivers, lakes, and ponds give off water vapor to the air by slow evaporation.